Hello, welcome to this lesson where we want to prove that the square root of 2 is an irrational number, all right? Proof. All right, in order for us to prove, we prove by contradiction. We can prove by contradiction. That is, let's suppose that let's suppose that let's suppose that this root of 2 all right, sorry for that. Let's suppose this root of 2, suppose it is rational, all right? Now suppose that root of 2 is rational. Okay, what does this imply? This implies that this root of 2 must be equal to a divided by b, all right? Every a and b are integers. And they're integers. Also that b must never be equal to 0. And that a over b should be in its lowest terms. In other words, it has to be simplified. All right? Now, we can try to get rid of the square root by squaring both sides. So we square both sides. And obtain the following. So we have square root of 2 to the power 2 is equal to a divided by b to the power 2 squared. This implies that square root of 2 is a 2, a squared divided by b squared. All right? So this further implies that if we solve for a squared will be equal to 2b squared. Now, we are saying a squared is equal to 2b squared, implying that a squared is an even number, all right? Is an even, because even numbers are those that are defined by 2n, for example. So is an even number. We can even say since it is a multiple of 2. All right. Now, also, if a squared is even, then a is even. All right. So a is an even number, implying that if a is an even, a can be found by multiplying 2 by any number, let's say r. Right? For this, r is, we can even put n is an integer. So it simply means if it is an even number, it simply means we can get the same a by multiplying 2 by a number, as long as that number is an integer. All right? Okay. Take note, we can call this, maybe we can call this expression equation 1 for reference. Then this equation, we call it equation 2. I hope that is okay. I hope that is fine. Now we do the substitution. Now we substitute a, all right, in 2 into 1 and obtain and get the following result. Okay. So what are we saying? We are saying equation 1 is a squared is equal to b squared. So we have got equation 1. I'll try to write it. Equation 1 is a squared is equal to 2b squared. So where there is a, we replace. So we'll say 2r squared. And this is the 2b squared. So working this out, what we get? 4r squared is equal to 2, turn it off. Turn it off. 2b squared, sorry for that. We can divide by 2 both sides, implying that b squared is equal to 2r squared. Now, so we are getting b squared by multiplying 2 by r squared. What does this mean? This simply means b squared is even, since it is also a multiple of 2. So if b squared is even, this implies that b is also even. Now, because we are saying a is even and b is even, we arrive at a contradiction. Hence, we arrive at a contradiction. Now, you can never have even, maybe let's say an even number, maybe 4 and 2, they are both even. Simply means they are not in their lowest terms. As long as 2 can still divide, it means they are not in their lowest terms. Because for us to discuss rational numbers, there must be fractions and in their lowest terms. Now, because we are dealing with both even numbers, maybe 8 and 4, all right? It means such fractions are not in their lowest terms. Hence, they are not rational, which is a contradiction. And if they are not rational, then they must be irrational. All right. So we are saying we arrive at a contradiction. We arrive at a contradiction. We arrive at a contradiction. At a contradiction. All right. Since we're giving the reason, we can still divide A over B by 2 as both are even. As both are even. Implying that A over B, we say A over B, which is both even, is not in its lowest or simplest form. So you give rational numbers, or you deal with such fractions when you have the lowest terms or simplest term. So not in its lowest or simplest terms. It means we can still divide by 2. All right? Hence, we can say hence, all right? The square root of 2 cannot be written in the form A over B. So the same square root of 2 is not a rational number. Is not a rational number. So if it is not a rational number, then it is irrational. Therefore, this proves or shows that root of 2 is irrational. And this concludes the proof, is irrational. That's it. Because our supposition was that root of 2 is rational. Now, when we got A was even. And when we got B was also even. Meaning that they are even. And because they are even, it means they can still be divided by 2. And as long as you can still divide, it means it is not in its simplest form. All right? It means it's not in its simplest form. Therefore, then that root of 2 cannot be written as A over B. And because it cannot be written as A over B, it can be written as A over B if it is in its simplest form. But in this case, it is not in its simplest form because we are still dividing by 2. And because it's not in its simplest form, it simply means it's not in its simplest form because we are dealing with both even. And because it's not in its simplest form, it simply means it is not rational. Because for it to be rational, it has to be in its simplest form. I'm trying to re-emphasize so that you get the point. So because it's not in its simplest form, it simply means it is not rational. And if it is not rational, our conclusion therefore is that it is irrational, because it's not rational, it is irrational. And this concludes our proof. Okay, please subscribe and share. All right, in case you want to contact us, you can contact us on the following numbers: 978 56 58 76. This is Mr. Phiri. All right. You can also contact us on 0979 67 38 09. This is Mr. Mbondo. Right. You can as well subscribe to our new channel, all right, which we are promoting for more videos of such nature. Till next time, it has been Phiri Kambale. Bye-bye. Tapi